Okay, here's some more problems from section 4.5. This is number 5. Now again, remember when you're doing the sine, just remember what the period is. Normally 2 pi. And again, just to review that, so this is my x-axis, this is my y-axis. And I think in this one it's going to be y equals the -3, so I need to kind of expand my vertical axis just a little bit. Make sure it goes up to 3 and down to 3, so actually use a ruler here. It's nice when you use a ruler. Okay. So I can put my scale here at 1, 2, 3, -1, -2, -3 for this particular function. And again, remember the period of the sine of x is 2 pi. So that's my period. Then we just divide that into 4 subintervals. So this would be pi, pi over 2, and 3 pi over 2. And remember for the sine, and they want you to graph the sine first, so that's nice. You get lots of practice with this. So we'll graph in pencil y equals the sine of x. And we always do this the same way. What's the sine of 0? The sine of 0 is 0, so it starts here. And then pi over 2, the sine of pi over 2 is 1. You should know that from your unit circle and your quadrant angles. They call those the quadrangles, the ones on the line. So pi over 2 pi, the sine of, so you just remember you could look at your unit circle and you look at those points like we did today in class. This is 1, 0, 0, 1, -1, 0, and 0, -1. And remember the sine is the right coordinate, it's cosine sine. So here's our 0, here's our 1, here's our 0, here's our -1, and there's your 0. So those are the 4 points. Okay, and then we just graph it. So it's real easy to graph. You just need 4 points, and then it's connected with a smooth curve. So that's your sine. Okay, and like I said, it's just you go to 1, and it's real easy to remember as long as you remember the sine of 0 is 0, then you go 0, 1, 0, -1, 0. Just like that. And then we want this graph. Now this is going to be y equals -3 sine of x. So now we're just going to put a negative, and then you could put the numbers in here. What's the sine of 0? 0. -3 times 0 is 0. You could do it like this. What's the sine of pi over 2? Well, that's 1, but times -3 makes that -1. So instead of going up 1, I go times -3 makes that -3. So I go down -1, 2, 3, so that's going to actually be down here. Try to line that up. And the sine of pi is 0, and that's going to stay the same, because -3 times 0 is 0. And then the sine of 3 pi over 2, the sine of 3 pi over 2 is -1, but if I multiply that by -3, I get +3, so that goes up here. And then back to 0, so that's our graph. I kind of ran over my, guess I wasn't thinking ahead too well, was I? No. Kind of curve that around there so it looks something like that, and that'll give you an idea of what it looks like. And it goes up over like this, okay? So again, this is y equals -3 sine of x, okay? And then this is y equals a sine of x. Okay? So if that makes sense. There you go. Something in that order, then you can always kind of fill it in because I kind of need to get a good enough curve on that, okay? Alrighty, let's take a look at number 7. Number 7, the sine of 2x. Now we've got a number in here, so now we're not dealing with the amplitude, we're talking about changing the period. Now remember, if we have this, if y equals the sine of bx, b is the number in front of x, remember the period was given by this very important formula, period equals 2 pi over b. Alright? So in this case, b is 2. So my period equals 2 pi over 2, which is just pi. So now my period is going to be pi. Now, depending on how I want to do it, I could do it to scale, and sometimes that's good because we've been using the scales. That helps you keep an eye in mind what everything that's going on. So I could do that, and I could actually just keep the same scale as I did in this number 5, so it would give you a good comparison. So let's do that. Okay. So we'll label our graph here. This would be y, this would be x. And if this was 2 pi, and this was pi, and this would be pi over 2, and since my period is pi, I'm going to divide this into the 4 parts to get one complete period. So I've got to mark this now, and this. And half of pi over 2 is pi over 4. And if I've got this as pi over 4, that's 2 pi over 4, 3 pi over 4, 4 pi over 4 is pi. So you could think of it like that, so this would be 3 pi. Now over 4. And if I want to just keep the scale like this so you can see the comparison, I could call this 1 and this negative 1. And again, the sine of 0. Now there's no amplitude change, so the sine of 0 is 0. Then the sine, and again, this is the whole period, so then I go, each of my subdivisions is like that. It's real easy. As soon as you've divided the period into 4 sub-intervals, or 5 points, those 5 points are always going to be, if there's no amplitude change, 0, 1, 0, negative 1, 0. Always those 5 points. 0, 1, 0, negative 1, 0. Always. And if you forget where to start, or you start, just figure out what the sine of 0 is, and that's 0, and then you go to town. 0, 1, 0, negative 1, 0, and there you go. It's like real simple. It's always the same. You just have to get the period defined and divide that. Okay? Now it would go again. There would be another period over here. But just to keep it consistent, we do one period. But if we did another one, I could just divide this into 4 equal subsections. I do the same thing. 0, 1, 0, negative 1, 0. And I could get another period. But it's going to repeat itself. That's what they call them periodic functions. So it's just going to repeat itself like this. And I can do the same thing. I would just have to mark off another 2 pi. Okay? So this is one complete period or one complete cycle. And you can see the difference between, this is the sine of x with a period of 1. I'm sorry, with an amplitude of 1, excuse me. The period's 2 pi. And this is the sine of x. Okay? But only with a period of pi. Same amplitude, y equals the sine of 2x. And if we look at the acoustical aspects of these curves, this would be a lower note than this. This note would be exactly 1 octave higher than this note, although they'd have the same volume because their amplitude's the same. The amplitude determines the volume of the sound. Okay, hope that helps.